I bet that you could do this math proof, showing that if n is odd, then n squared is odd. Even if you don't have a lot of proof experience underneath your belt, I think you can follow this one pretty easily. Let's try. To start us off, we'll go through the definition of what it means for an integer to be even or odd. So an integer n is defined as even if there exists an integer k, right, k within z, such that n is equal to 2k. So just think about your even numbers, right? 2, 4, 6, 8. These can all be expressed as 2 times an integer. 2 is 2 times 1. 4 is 2 times 2. 6 is 2 times 3. You see what I mean? And then an integer n is defined as odd if there exists an integer k such that n is equal to 2k plus 1. So think of your odd numbers, right? 1, 3, 5, 7, blah, blah, blah. These can all be expressed as 2 times an integer plus 1. 1 is going to be 2 times 0 plus 1. 3 is going to be 2 times 1 plus 1. 5 is going to be 2 times 2 plus 1. You see? Now let's see if we can't use those definitions to do this proof. So what we're first going to do is assume that n is odd. Okay, if n is odd, then there exists an integer k such that n is equal to 2k plus 1, per our definition. All right, so now that we have that, let's keep in mind our final goal, which is to show that n squared is odd. So eventually, we want to show that n squared is equal to 2 times an integer plus 1. So why don't we just square both sides of this and see if we can't do some steps and manipulate it so that we end up getting 2 times something plus 1 is equal to n squared. When we square that 2k plus 1, don't you dare distribute that, right? We all know that that's 2k plus 1 times 2k plus 1, and then we do our little foiling, so that's going to give me 4k squared plus 2k, so plus 4k plus 1. Okay, this last line, can we make this look like 2 times something plus 1? I think we can, right? Why don't we factor a 2 out of those first 2 terms, and then we'll get 2 times 2k squared plus 2k plus 1. Now all that's left to show is that 2k squared plus 2k is an integer, right? Because we've shown that n squared is equal to this. This looks like 2 times something plus 1. We just got to show that that something is an integer. But this is pretty easy, right? Because k is already an integer, and integers are closed under addition and multiplication, meaning that if you take an integer plus or multiplied by another integer, you're still going to get an integer. And there we have it. Because we've shown that n squared is equal to 2 times an integer plus 1, we've shown that n squared is odd. QED, baby. QED. Quadrate demonstratum. I think that's what it's Latin. It's something. It means that we're done with the proof. Just looked it up. It's quadrate demonstrandum. So